Don't step on this. We're not supposed to step on ours. That's for your shoe covers.
So, this is where I grow my cells, and these culture hoods, and everything's sterile in there, and that's, my cells are actually in this incubator right now, growing themselves nicely. And, that's cells. And then below this, I just made a lung bioreactor, which you can kind of bend down and see. It's just
Can you take it out or not? Can you take it out so we can see it?
No. I mean, you can come see through the glass. It's just a decellularized lung matrix of a mouse that I made, and it's hooked up to a pump so that it's breathing, basically.
Are you taking pictures of all these things as you do them?
Yeah. Yeah. So you guys can file in and look at them because they're kind of cool. And mine's the one on the very left, and it's my baby.
Yeah?
Yeah.
Oh.
I have a question.
Why exactly do the cells need to be placed in this tank?
In the incubators?
Yeah.
It just has the right temperature and right levels.
Jessica, what's this?
What?
This thing. It looks fancy.
What?
This thing.
That's a centrifuge.
Oh, a big one.
Yeah.
Okay.
So would the patient's stem cells be used to make the lungs? So then it wouldn't like have any problems with being
Rejected. That's
yeah,
right.
yeah, yeah.
Exactly. Excuse me.
Sorry.
You guys saw the pig lung in there?
I took a picture of it.
Oh, good.
Do you guys stay here because we're going to introduce you? Stay here.
We can go in the hall. It's
Okay,
kind of
let's go in the
contained
hall, yeah.
space in here.
Back.
Oh yes, this is my advisor, Dr. Murtari. She's awesome. She just checks up on me and see if I'm doing everything I should be and not breaking everything I touch. So, yeah.
So Dr. Mortari's daughter is also doing research here, and she'll be at the science fair, so I've encouraged Jessica to invite her to your lunches so you can get to know her.
Yeah, she's really cool. She's downstairs.
Yeah, she's in another lab downstairs.
What's she working on?
She's working on using immunotoxins to she's testing an immunotoxin against different cancer cell lines to see which ones will be killed most efficiently. Other immunotoxins that are actually in clinical trials. So it's yeah, it's pretty exciting. There are other cancer cell lines.
She's right there.
There she is.
Introduce her.
This is Marissa.
This is my class.
This is Jessica's class. This
We're
is,
going to be at the science fair
Froman.
together.
Hi, nice to meet you.
This is Marissa. And so I was telling them about your project. Explain your project.
Oh.
You gotta point toward them or they won't hear you.
So I'm testing different cancer cell lines and using this new immunotoxin to kill it. Right?
Yeah. But what part of it is it that we're trying to kill?
Like the cancer
stem cells.
Cancer cells.
So do they just target cancer cells versus healthy cells? Really?
That's the idea.
Wow, that's fantastic.
And so these immunotoxins are targeted against certain molecules that are overexpressed on cancer stem cells. So every tumor isn't identical, even though it proliferates and expands out of control. Every cell is actually not identical to the next cell. And so the reason that a lot of patients relapse after chemotherapy is now the new theory is that because there are cancer stem cells that don't get killed by the chemo because they self-renew constantly. And those are what can perpetuate the tumor and then transfer the tumor serially into other animals or continues to say. And so anyway, so the idea is if you can kill the stem cell, then that'll cut it at the root.